The next one, question number 4, was a question on complex number. But sincerely, you didn't need to know too much about complex number because I gave you all the information here. I already told you I squared is minus 1. So it means you should just be able to see how you can play with this. So we're supposed to look for this value. What does this simplify to? So if somebody comes with a hair like this into the salon, can you make it beautiful? And that's what we do in the math salon. So 1 minus I to the power 3 alpha divided 1 plus I to the power alpha can be written as 1 minus I to the power 3, all that to the power alpha divided 1 plus I to the power alpha. I can expand this a cubic term, so you can actually expand it. You can do that. So if you have something like A plus B, maybe I'll do it that way, that is easy. So if you have A plus B to the power 3, and you expand it well, then this is A to the power 3 plus 3A to the power 2, B plus 3A, B to the power 2, plus B to the power 3. That is the expansion of this. So I'll use that here. If that is true, then my A is 1, my B is minus I. So this will be 1 here to the power 3 plus 3, 1 to the power 2 minus I to the power 1 plus 3, 1 to the power 1 minus I to the power 2 plus the last one minus I to the power 3. All this to be to the power alpha divided 1 plus I to the power alpha. Let's arrange that well. If we look properly there, I have 1. This is just minus I. 1 squared is 1. That's going to give me minus 3I there. This here, minus 1 squared is plus 1. But I squared is minus 1. And this becomes minus 3. Minus 1 cubed is minus. But I cubed is I squared times I. So I'll write that a little. That is a little tricky. So here, this is plus minus 1 cube I cube to the power alpha. 1 plus I to the power alpha. Minus 3 and 1, I already have minus 2 there. So this I cube is I squared times I. But I squared is minus 1, so this will be minus I here. But because minus 1 is also to the cube is also minus 1, the minus now changes it to plus. So then I get here minus 3I plus I, all that to the power alpha divided 1 plus I to the power alpha. 3I minus 3I plus 1I is minus 2I. So this is minus 2 minus 2I, all that to the power alpha divided 1 plus I to the power alpha. I can factorize minus 2 here. Then that will be minus 2 into 1 plus I, all that to the power alpha, 1 plus I to the power alpha. AB to the power n is A to the n, B to the n. So I can split that down. So this is minus 2 to the power alpha times 1 plus I to the power alpha all over 1 plus I to the power alpha. These two falls off and it's minus 2 to the power alpha. And that was the D answer. Question number 4 was, given that alpha, beta, and minus I are cube roots of this number, this complex number, find this value here. The cube root of number simply means that number to the power 3 would give you that answer. So if the cube root of 8 is equal to 2, that means 2 to the power 3 is equal to 8, right? That's the idea. So it means that this number, when you cube, is going to give you the information that you need here. So for example, I can write this as z cube is equal to I. So if I take alpha and I cube it, I should get I. If I take beta and I cube it, I should get I. If I take minus I and I cube it, I should get I. In the original question there was a small typo. So you had minus I here instead of that. But that was not too useful because the question did not ask you about this minus I. It asked about the alpha and the beta. So if I have that information, then I said, if this is a cube root, it means that alpha cube is equal to I. Beta cube is equal to I, because that's the solution to this. So if each of that is put here, you should get that answer. So if that's the truth, then means I will try to make sure I play with this to get something that's to do with cube. So I can write this as to the power 3, all that to the power 2k, plus beta to the power 3, all that to the power 2k. This I already saw is supposed to be I. So that's I to the power 2k. Plus here, I to the power 2k. This is just the same thing twice. So this is 2, I to the power 2k. But I can also play with the 2 and the k. So this is 2, I to the power 2, all that to the power k. I to the power 2 is minus 1. That's what indicated about a complex number. So this is here 2 into minus 1 to the power k. I is to minus 1 together. So that was supposed to be answer number D. So our next question, or the question number 6, was we're given 1, 2, 3, 4, 5 polynomials here. And we asked to check which of these, how many of these have factors that will be lower than the original degree of the polynomial itself, and then making sure that the coefficients are all real coefficients. If we check that well, we could start from here. If I start from here, I can already see, for example, that x to the power 6 plus 1. I need factors of this that can work, that can give me some ideas here. So for example, if x to the 6 is equal to minus 1, then it means I should be able to play with this to get, for example, x squared to the power 3 is equal to minus 1, and the cube root of minus 1 is minus 1. So x squared plus 1 is a factor there. So I already have one factor for that one. So this one is 1. Checked. X to the power 5 plus 1 equal to 0. So if I look at this, if x is equal to minus 1, then minus 1 to the power 5 works. So I already have a factor like x plus 1 into blah blah blah. So this can be factorized. So I look at the next. X to the power 4 plus 1. This is the one that looked a bit tricky. But actually if you check that well, it's just x squared here plus root 2 x plus 1. X squared minus root 2 x plus 1. These are the factors of that one. So this could also be factorized. X cubed plus 1. If I put x squared to minus 1, it works as well. So x plus 1 here. And some other factors. That's okay. Then get that is just x squared minus x plus 1. If you want to see, that's okay. The only one that could not be done this way and we get real factors is this. Because x squared equal to minus 1, you can't have real factors for that. So it means there were 4. The answer was 4 for this. 1, 2, 3, 4 of them. For this question, we're given two functions like this. F of x is equal to x squared minus 4x plus 4, and g of x, which was 4x minus x squared. And we're told to look for the area bounded by these two curves. If the two curves bound an area, it means that they have to intersect at least 2 points. So you have to have something that bounds. If you look at the coefficients of the x squares, then you can already have an idea. For example, this is minus 1. So this is a maximum function. So it goes something like this, say. And if I look at this one, the coefficient of x squared is positive. So this is a minimum function. So it goes something. Don't mind. I cut this because I know that I can solve this and get the points where they intersect. It's just a coincidence. You just have to make a sketch. It's not too important. In order to look at these points of intersection, we have to equate the two. Because at this point, the value there holds for both functions. So to do that, we equate the two of them to know which are these coordinates, because we need it to integrate and get this area. If I do that, then I get here x squared minus 4x plus 4 is equal to 4 minus x squared. If I take x squared this way, I get 2x squared. If I take 4, it becomes minus 4, it falls away. I get something like that. I can factorize 2x, and I get 2x out is x minus 2 equal to 0. So this 2 gives 0 means either this is 0 or that is 0. So 2x is equal to 0 or x minus 2 is equal to 0. So there are 2 points, x equal to 0 and x equal to 2. So it cuts at this point and this. So this should be 2 here. We can look for the corresponding y, but that's not too important for me here. So what I need to know is, in order to get this shaded area, I will have to look for the integral of the two separate functions here. This is my maximum function that we said. There you can see that. Maximum function. This is this one. So that's 4 minus x squared. And that is the minimum function. That is that one. X squared minus 4x plus 4. To get this shaded region, definition of integral as a way of calculating the area under a curve says it is the area that is under. So if I look for the integral from 0 to 2, for this function, for example here, I will take the bigger one first. 4 minus x squared dx. That means everything under this here, everything. But I don't need everything. I need only this part. But then if I take the next one, 0 to 2 of x squared minus 4x plus 4 dx, then it is only this one under here. So if I take everything and remove this one under, then I have that. So it means the area I'm looking for would be the integral of this bigger one, that is the one that is there, minus this smaller one. 0 to 2, 4 minus x squared dx minus the integral from 0 to 2, x squared minus 4x plus 4 dx. Since I have the same limits, I can actually put all the function parts together. So this is going to be integral from 0 to 2, 4 minus x squared minus x squared plus 4 minus 4 dx plus 4x. So you see this 4 here goes off with that one. So this is a much simpler integral, minus x squared, 2 of them, plus 4x dx. So if I integrate that here, then this is going to be, we increase the power, minus 2/3 x cubed plus 4x squared on 2 from 0 to 2. The 0 falls away. So I have only 2 to substitute in. 2 to the power 3 is 8. 8 times that is minus 16 on 3 plus 2 here 1, 2 here 2. So 2 there is 4 times 2 is 8. If I put that together, then yeah, I'll try to make them have the same denominator. They become 24 on 3. 24 and that gives me 8 on 3. So the answer was 8 on 3. For question number 9, was that number 9? Number 8. Question number 8, we are asked to look for the maximum of this function here. Let's say that function is f of x. Let's call it f of x. 1 over x squared minus 4x plus 7. This is a polynomial in the denominator and yeah, just a constant number at the numerator. So we can say that this is like a rational function. So this function is only maximum when the bottom part is minimum. As the bottom part grows, then this number becomes smaller. So this number has the biggest value when the denominator is smallest. So it means we can just look for the minimum of the denominator and that will give us the maximum of f of x. So let's say g of x is equal to x squared minus 4x plus 7. There are several ways you can look for the minimum of that number there. We see that it's a minimum function because the coefficient here is positive. Say, so if it was maybe in secondary school, I will not apply a derivative. We will just say that the turning point coordinate of x is equal to minus b on 2a. If you do that here, that is minus 4 divided by 2 times 1. And that is 4 on 2 and that is 2. And I can use that number and substitute to look for g of 2. If I do that, this is 2 squared minus 4 times 2 plus 7. And this is 4 minus 8 plus 7. And that is minus 1, that's 3 here. At high school, you can also apply derivative. You know that if you differentiate the function, it gives you how the gradient of the function varies. But if the gradient is 0, it means that there's a point where the function is changing its direction. So in that case, you can also say the g prime of x as a derivative, that is 2x here, minus 4. This should be equal to 0 if that is at the minimum or its maximum. So in this case, it's a minimum because we know that this is a minimum function. So this means 2x is equal to 4 and x is equal to 2, and you can do the same thing. So my minimum g of x is 3. So max f of x is 1 divided by minimum of g of x, and that's equal to 1 all over 3. That was the answer for that one. So for question number 9, this is actually a question that was already there in the quiz for Douala. I also shared this and it was online in my SALON. So the idea was that when you are preparing for the quiz, look for all what is available and prepare. And also learn, that's the most important. So this quiz was already there and I brought the question again. So here we are asked to find the remainder when the square of the sums of that is divided by 5. That was the idea. So it has to be the square of the sums of factorials of natural. So there are a number of things here. Factorial, natural numbers, the square, and sums. So first we have to look for natural numbers in this. So the natural numbers x is an element of n means x would be, I look for natural numbers that are here. Here we get 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the natural numbers in this interval here. So we asked first to look for the factorials of this number. We already learned before, n factorial means n times n minus 1 times n minus 2 up to times 2 times 1. So for example, 2 factorial is 2 times 1 and that is 2. 3 factorial is 3 times 2 times 1 and that is 6 and so forth. So let's just make a small arrangement here. So if I start 1 factorial, this is 1. 2 factorial, this is 2. 3 factorial is 6 because it is 2 times 3. 4 factorial is 6 times 4, that's 24. 5 factorial is 120 because 24 times 5. Notice that from here up to here, the numbers don't have a 0. But from here, if you continue up to 9 factorial, they all will have a 0 because each time it's multiplying the previous number. This was obtained by 2 multiplied by the previous number. This was obtained by 3 multiplied by the previous number, and so forth. So if I sum these three here, 24 plus 6 is 30. 30 plus 2 and 1, that's 33.